ado, I'll introduce Brian.
Thanks, Ken. So we'll look at a number of experiments here, and what you'll find is they all feed into two themes basically. And when we wrote the proposal, we were looking at trying to improve two things with winter wheat. One was stand establishment in the fall, and thereby improving crop health and competition, and hopefully translating into good and improved yields. And the other thing is a focus on integrated crop management, and so that can involve experiments dealing with pests such as weeds, diseases, or insects. And so you'll see we've got some, we're looking at new chemistries in downy brome and Japanese brome, for example, seed treatments, fall foliar fungicides, that sort of thing. So what we'll do is we'll just sort of do a big loop through these series of experiments here, and Ken can keep an eye on time and sort of gauge me as we're going along here. One of the things of interest to winter wheat producers is the utility of seed treatments in the fall, and whether or not that can influence stand establishment of their winter wheat. And so we're looking at a series of experiments with that, and we're looking at both Syngenta products and Bayer products with that. And so as an example, one of the experiments that we have is this one behind me. This one here is funded by the Western Grains Research Foundation. It's a new one that we just planted last fall. And we've got both spring and winter wheat in this one. And this one's actually designed more for the fusarium areas, but this one will be an interesting one for us here as far as leaf disease management. So basically we've got susceptible and moderate to resistant cultivars in here, both spring and winter wheat, and then we're either using a seed treatment or not. We're either using a in-crop foliar or not, or we're combining both the seed treatment along with the in-crop foliar for this one. And we haven't applied the foliar yet, right, Ken?
Nope.
So you won't see much effect here. I just wanted to give you some background on what we're doing here. So if you'd like, you can follow me and we'll head down to the next set of experiments. So one of the things I should have mentioned is with all of these experiments, what we did is we partnered with the producer commissions of each of the provinces, along with Ducks Unlimited, and that's how we were able to leverage their industry contribution through an Ag Canada program called Developing Innovative Agri-Products. And so from the Alberta winter wheat producers' perspective, one of the things they wanted us to for sure look at was revisit downy brome management, but also the dynamic with brome management, of course, is the relatively newer brome, Japanese brome. And as far as distribution area goes, if you draw a line from here, maybe straight down to the border, the southeastern part of the province would be more of a natural distribution area for downy brome. The wetter southwestern region would be more of a distribution area for the Japanese brome. And so we're looking at traditional products here, but also some newer ones. There's a new chemistry out called pyroxasulfone, which is a group 15 herbicide. Initially developed for probably more the corn soybean market, but Bayer, as I understand, has it licensed in Australia for wheat and triticale. BASF will have it in the US for soybeans. Event, I believe, has it up here in a product called Fierce for, again, corn and soybean management. So we thought it'd be a good strategy to integrate it with this study as well. We're also integrating that with products such as Simplicity, which is, I guess, the go-to herbicide right now in terms of brome management from a suppression standpoint. We tried also Everest and what was the other one, the Bayer product?
Velocity.
Velocity, sorry. So we also, instead of just applying in the spring, we applied some of these in the fall as well. And so basically what we found with last year's results was Everest and Simplicity were giving us relatively similar results, but the fall applied Everest, we were seeing some phytotoxicity issues with that to the degree that it did reduce our grain yield. But relatively speaking, you know, good suppression with both Simplicity and Everest. And then the past fall, is when we started looking at the new chemistries such as pyroxasulfone. So you can, if you like, walk this way and you can decide for yourself what's working the best. We're starting with the weedy check here, which is weedy, right? And this is our Japanese brome experiment, and that follows with the downy brome. So if you want to head this way, you can have a look at the various treatments here. This is Simplicity applied in the fall.
I was going to mention on the very last page of this handout, we did just quickly put together our ratings for this year.
Oh.
So we have, and that's only this one site, one location, so don't take too much credence to it. But overall, excellent control with that new pyroxasulfate. There's a broad range of rates that we were looking at, but the higher rates were definitely some crop tolerance issues, but looks like there's a nice rate in there that did really great control on both Japanese and downy brome.
Yeah, and that's a soil applied herbicide that we put down. We didn't incorporate it, but we sprayed it, what, Ken, a few days before planting? Ken, when did you guys apply the pyroxasulfone?
For the fall one?
Yeah, just a few days before, or how did you do that?
Yeah, it was
but you didn't
basically at the time of season.
Yeah, oh, okay. Now the other thing that I should have mentioned was, one thing we encourage you guys to do, and we've said it many times, is that if you increase your seeding rates, you're going to improve your competition with weeds. If you're in a weedier field, you might want to reconsider and select a variety that might be taller or more competitive. We did the opposite here. I selected a shorter variety, CDC Falcon, and planted it at a moderate to low rate, which would be about 30 seeds per square foot or 300 seeds per square meter. So we wanted a weak system so we could really test and see how competitive these weeds could be and how effective in that weaker system these herbicides would be. So these last 4 plots here are the newer chemistries. Which one's this one here? Yeah, this is flumioxazin, pyroxasulfone at one rate, a higher rate, and then a tank mix of both here, which is called Fierce, that's being marketed downy. So keep on walking if you like.
Why is the plant stand forward here? Is it just because of how it was seeded, or is it the chemical?
I'll let Ken answer that one.
Well, so there is some phytotoxicity in the higher rates of the pyroxasulfate. There's also, there was this kind of suboptimum establishment of the winter wheat, considering the dry conditions that we had. We were, the canals were getting shut off, and we were this close to starting to irrigate because we had seeds sitting in the ground for 2 to 3 weeks and no irrigation. But when that rain came, then things happened.
Yeah.
What's this phytotoxicity?
That's what crop tolerance. So
Okay.
basically a growth reduction, or what I've been noticing would be a growth reduction, not necessarily a stand reduction. A stand reduction is basically less plants survive. A growth reduction is they're stunted.
Okay, so this is where we have those same treatments, but now in an environment with downy brome pressure instead of Japanese brome pressure.
Okay, this one's a lot easier. I'd like somebody to come up and find some downy brome in here so that you can take the two beside each other and really see the difference.
So here's an example of fall applied Simplicity to spring applied. We weren't getting as good of efficacy results with Simplicity applied in the fall. We were getting good results with Everest in the fall, but like I said, it was leading to some toxicity issues. So Simplicity, at least this year, and I believe last year as well, better to apply that in the spring, but like Ken said, you have to be kind of on it early. Fall Everest, though, worked a little better than fall Simplicity, for sure. So not registered, but the new chemistries are working quite nicely here in the downy brome trial, as you can see with this, these two plots right here. Okay, so now we're on to a different aspect of winter wheat management, and that involves managing weeds in either an optimal or a suboptimal stand. And one issue that we have from time to time with winter wheat is we have less than ideal plant stand. We either seeded too low, maybe had some issues with our equipment, or we just had a bad winter and we've got more winter kill than we would have liked. So what we've done with this experiment is we have 2 seeding rates, a low one of 150 seeds per square meter or 15 seeds per square foot, or at what I would consider an ideal plant population or a planting rate of 450 seeds per square meter. And then within those two systems, we're looking at, again, at a range of herbicides to see what kind of effect we're getting on cleavers and wild oats. Ken and the boys and girls, they underseeded this with both cleavers and wild oats, and I think you'll see quite a difference between an optimal stand of winter wheat versus suboptimal. We've got that new chemistry in this one as well, the pyroxasulfone, and we're really jacking up the rates on it in this one, and I think in this case you'll probably see some stand thinning from those really high rates that you guys applied in the fall of pyroxasulfone. So the first rep's randomized, so we'll just head down to the end of the range, I guess. So starting with this one here, we have, here's your lower seed rate. You can see how it looks thinner than, say, this one where we've got more of an optimal plant population, and this is the pyroxasulfone here and here, both at the same rate. Do you have one that's really loaded with weeds? This is a good example of some of the stand thinning that we're seeing with that higher rate of pyroxasulfone, particularly when you're starting with a low plant population in the first place. This is a very high rate in two different systems, so that's the low seeding rate, this is the high seeding rate, and you can see how much more negatively affected that lower seeding rate is being affected by that higher rate of herbicide.
Okay, we've got weed challenge number 3. This isn't a weed that's necessarily common to southern Alberta, but is a really big issue, especially for the canola industry, because the seed size is very similar to the size of canola. It's very difficult to clean it out, and it causes really big issues in extracting the oil because it contaminates it. So Western Canada-wise, cleavers is a huge issue. I'd like to pick a nice rep from UFA to come in here. UFA is actually our industry sponsor, so they have to find me some cleavers to prove, you know, it was money well spent. Oh, I was holding
Go,
responsible.
Daryl. Did you want to get the expert? You're sure I can find him in here?
I'm sure you can find them in here.
Covered.
Oh, that was fast. So take a look at this. If you start to see this weed, take serious attention to it. It can wreak havoc in canola fields in particular. Basically, what we found throughout rating all of these trials is that most of our options were really good for control. I worry that because it was we seeded the weed in the fall, that it really didn't get a chance to get established with some of those fall herbicides. But even things like Axial and Trophy together, we did manage to get really good control on almost all of our plots, of course, except for the untreated check.
So one issue with a lot of canola growers across the prairies is timing and crop sequencing. One thing that we're seeing with canola, for example, is that even though it's our ideal stubble to plant into, the yield bar is being raised not so much through, I would say, genetic potential, but essentially we're raising the yield potential on canola by raising the growing degree day requirement. So we're getting later and later maturing canola, and it's making it harder for winter wheat growers to sequence in behind canola, particularly in shorter season areas like east central Saskatchewan, northern Alberta, that sort of thing. So this experiment, what we're starting to look at is opportunities to crop in behind stubbles alternative to canola, and that would include pulses, barley. We even had in behind me here spring camelina stubble and fall camelina stubble. We dropped the fall camelina planted stubble. That didn't work out so well, but we do, this one here as an example is cropping in behind a crop of spring planted camelina. And as you can see, in this particular site, we had some pretty good pressure competition from volunteer camelina that's continuing to compete, steal some nitrogen and other resources away from the winter wheat, as opposed to going in behind something like a pulse crop that was previously planted to a cereal stubble. So not going to spend too much time on this one, but just to give you a heads up as to what this part of the project is all about, and it's all about enhancing both stand establishment but crop sequence opportunities with different crops that are out there. One of the other areas of the project is looking at integrated nutrient management. We've done a lot of work with controlled release ureas, split applications and timings and that sort of thing. The next stage that we've moved on to is a study headed up by Dr. Guy Lafond out of Indian Head, and he's doing this in both canola, spring wheat, winter wheat, and a lot of crops, and it involves using optical sensors such as the green seeker for precision timing and application of your nutrients, and so and in this case nitrogen. And so there's two experiments here, and basically the goal is to develop an algorithm for that green seeker tool that's specific to Western Canada. It's an instrument that's developed out of the US and just starting to make an appearance into Western Canada, but using their algorithms down there to calibrate to our situation isn't really a good idea. And so he's looking at all different crops. And so the first stage was to take 5 of our relatively common varieties and impose them to 5 different rates of nitrogen. And then the second stage is the one you see here, where he's taken a whole range of either banded or split application scenarios at different, from low to extremely high rates. And then what we do is we go along with our green seeker instrument, and basically what we're doing is we're getting a gauge for how green that plot is. And in this case, you can see when we go too much with the nitrogen, we get the burn on there, and that'll be reflected in the green seeker data as well. So this will be a pretty cool thing that'll give, when the time comes, winter wheat producers that want to adopt that kind of technology, a more specific algorithm and more reliable system for Western Canadian conditions. Okay, this is one of the experiments I alluded to at the beginning of when we first got together, and this involves the variety CDC Buteo, and we've got factors going on here that include seeding rate, quality of seed, and with or without a dual fungicide, seed-applied fungicide insecticide. So we've got 3 factors going on here that really you can create a range of agronomic systems from very weak to very strong. And so for an example here, we've got, we took that seed lot of CDC Buteo and scalped it over a cleaner so that we had very plump seeds, very thin seeds, or just the regular lot that we would have bought that you would plant yourself. And so here's one where we've got a low plant population of 200 seeds per square meter. We're using the very light seed, so that's an indication of probably weak seed vigor. And then we did not put any seed treatment on it. Same system here, but we've used the seed treatment. And this is again what we saw last year as well, is that you definitely in a weaker system, from both a visual and then as it translates into a significantly higher grain yield at the end of the year, the advantage of going with a seed treatment in a situation like this gives you quite a stark improvement. Whereas when you go to a stronger system, which is what we have up here, so we've got the same light seed here, but we've got a higher plant population, and we've put the dual insecticide fungicide on this one, and you don't really see the same sort of situation that you would see whereas if you did not use it at all. And I guess from my standpoint, where you make the recommendation, I think when you do the economics, which we did last year, the seed treatments pay for themselves. And so in my mind, they make for probably a good insurance of maintaining that high yield potential, what you're shooting for. And so I wasn't sure where it would fit in terms of how it would shake out in terms of the economics, but both the agronomics and the economics, in my mind, probably support the use of it. So we've got one last experiment to look at here involving foliar fungicides. Okay, so this final experiment that you see from here, headed that way, This involves a more detailed investigation into seed treatment effects. And in this situation, we've taken 5 levels of seed treatment, from control to no seed treatment at all, to looking at the chemistries independently, as well as this last plot here, which has the combination of Raxel WW in it. The other interesting aspect to this study is we were interested to see what sort of effect you would get. Instead of applying your in-crop foliar fungicide in the spring, what would happen if you applied it in the fall? And the fall of 2010 was a very good time to do that, because we had 3 sites that almost reached epidemic proportions in terms of stripe rust infection. And that was us down here in the south, Scott, Saskatchewan, and if you can believe it, Melfort, Saskatchewan, which was probably the worst infected of those 3 sites that had stripe rust in the fall. And by applying, in our case, we used Proline. We applied about mid-October, as opposed to not using any foliar fungicide at all. We significantly improved grain yield. So what I would suggest is that, particularly for us in southern Alberta, where we can routinely get stripe rust building up in the fall, is that you scout your fields in the fall. And if you're seeing quite a bit of leaf infection, the idea of going to a fall application would be probably a prudent thing to consider.
What rates, Brian, did you use in the fall?
The label full label rate.
Was there any last fall?
We didn't see as much last fall. A few reports, but not like it was in the fall of 2010. That's for sure.
Anything showing up at all this spring?
Well, I think it's going to be something that's on the horizon that it should be looked out for 2 reasons. One is the rust trajectory that Kelly Turkington reports and follows seems to indicate that we could be, the conditions could be building for heavy stripe rust conditions. The other thing is that race has shifted a bit, and so some of the varieties that were resistant, some of the genes that were resistant have broken down a little bit. And as an example, Radiant for winter wheat was actually not bad for stripe rust resistance. That is broken down, and so there's going to have to be a little bit more due diligence in terms of monitoring stripe rust this coming year for sure. Yeah, that doesn't surprise me, although it's well, and the conditions are great for any kind of disease. I think Rob commented too on a lot of our plots here. We're getting some pretty not yet willing to pull the trigger, but we've got some pretty good disease load building up in here that we're probably going to have to deal with as well. And so the way I saw most of our plants is that our flag leaf for sure is not infected. The penultimate or one down from the flag isn't really all that infected, but our third leaf in a lot of cases is affected. And so we'll probably be hitting a lot of these experiments with an in-crop foliar, unless there was a in-crop foliar as part of the treatment plan. So Ken, I think that wraps things up.
For the in-crop foliars, would you go with something on the cheaper side, or something more expensive like Rumba or Prosero?
Always more expensive.
Or can you get the job done with
Well, do you drive a Chevy LTZ or a Chevette?
It's an 03.
They both
Yeah.
get you the same place though, Brian.
Well, sometimes you get what you pay for, though.
Yeah. Well, if you're spraying on the flag leaf, could you get away with a cheaper one?
I don't know. I don't think we have enough data I certainly don't have enough data or research experience myself to say. We're using Prosero in the WGRF trial for our in-crop spring foliars. So we have a luxury of not having to consider the economics until we're finished to make that recommendation to you on whether or not. We'll probably be expanding those aspects. This is the final year of this particular round of funding, and we'll be gearing up to investigate new topics, consider new topics, and continue on with some of the stuff that we've started. So there's a research topic that you would like addressed that you don't feel we have, just get in touch with us.